Welcome to Ask and Learn.
Our question is: an air standard dual cycle has a compression ratio R is equals to 20 and a cutoff ratio Rc is equals to 1.3. The pressure ratio during the constant volume heat addition process is 1.2. Determine the thermal efficiency. I have to find the thermal efficiency, amount of heat added, that is Qn, and the maximum gas pressure and temperature when this cycle is operated at 14 psi and 70 degrees Fahrenheit at the beginning of compression. Use constant specific heat at room temperature. So in this question, properties of air are also mentioned in the table, that is 0. R is equal to 0.303704 into feet cube per IBM dot R, where Cp is equals to 0.240 British thermal unit and Cv is equal to 0.171 IB BTU divided by IBM, that is thermal unit, where K is equals to 1.4, and we have to find the thermal efficiency, maximum pressure, heat added, and temperature to be determined. So we have the P and V diagram in this question like this. First, this is the process Q1 to 2. Then there are two phases for heat to be added in the system. That is heat added. This is the point X, 3 and 4. Here is isentropic compression. There is an expansion. So now working around the cycle, the germane properties at the various state are: properties at various states are: first we will find T2, which is equals to T1 over V2 power K minus 1, which is equals to T1 dot R power K minus 1. Putting the values, that is 530 into R is 20 power 1.4 minus 1, which is equals to 1757 R. This is the temperature T2. Now there is pressure P2, which is equals to P1 V1 divided by V2 power K, which is equals to P1 R power K. That is 14 into 20 power 1.4, that is 928 psi. Now Px is equals to P3 which is equals to Rp R2 Rp P2 Rp P2, which is equals to 1.2 into 928 is equals to 111 whole psi, where Tx is equals to T2 Px divided by T2 is equals to 1757 R into 114 divided by 928, which is equals to 2109 R. Now temperature T3 is equals to Tx into V3 divided by Vx, which is equals to Tx Rc. Putting the values, we get 2109 into 1.3, which is equals to 2742 R. Now temperature T4 is equals to T3 into V3 divided by V4 power k minus 1, which is equals to T3 into Rc divided by R power k minus 1, which is equals to, putting the values, 2742 into 1.3 divided by 20 power 1.4 minus 1, and this comes out to be 1918.8 R. So applying the first law and work expression to the heat addition processes, we get, now apply first law and work expression to heat addition. It gives Qn is equals to, now we will find Qn, which is equals to Cv into Tx minus T2 plus Cp T3 minus T2, which is equals to 0.171 into 2109 minus 1757 plus 0.240 into 2742 minus 2109. This is equals to 212.1 British thermal unit. Now the heat rejected is would be Q out is equals to Cv T4 minus T1, which is equals to 0.171 into 918.8 minus 530, which is equals to 66.48 British thermal unit divided by IB. Then thermal efficiency will be equals to 1 minus Q out over Q in. That is 66.48 divided by 212.1, 0.687, that is 68.7%. So this is our answer. Thank you.